Hello. In this video, I'm going to be solving problem 31 from section 10.2 of James Stewart's Calculus Early Transcendentals. The problem reads as follows. Find the slope of the tangent line to the trochoid with parametric equations given here. And we want to find the slope in terms of theta. And they tell us to see exercise 10.1.49. That's just to get background on what a trochoid is. And I actually made a video solving this exact problem, 10.1.49. If you're interested, I will leave a link in the description. And for part B, it asks us to show that if d is less than r, the trochoid does not have a vertical tangent. So how do we proceed? Well, the first thing to remember is how we compute the slope of a tangent line when we're given a curve in parametric form, right? So let's suppose x equals f of t, y equals g of t, a less than or equal to t less than or equal to b, describes our curve parametrically. Then the slope of the curve that these equations draw out can be computed using the formula dy dx equals dy over dt all over dx over dt, where dy dt is just going to be g prime of t, and dx dt is just f prime of t in this case. So in other words, we take the derivatives of the parametric equations, and then we put the y derivative on top, the x derivative on bottom, and we divide. So this is the formula we're going to use to solve part A, which asks us again to find the slope of the tangent line to the trochoid in terms of the parameter theta. So let us begin. Now for us, we already have the parametric equations. They're given to be x is equal to r theta minus d sine theta, and y is given as r minus d cosine theta. Computing the derivatives, we see that dx d theta now. So notice that I'm differentiating with respect to theta because that's the parameter in our parametric equations. So taking the derivative with respect to theta, we're going to get, well, d theta of r theta is just r. And when we take the derivative of this sine, it's going to become cosine theta. Similarly, the derivative of the y with respect to theta, well, now we don't have a theta in front of the r, so that's just a constant, and it goes to 0. And taking the derivative, well, derivative of cosine is negative sine. So this derivative is d sine theta. Thus, our slope dy dx, which if you'll remember is given by this fraction right here, dx d theta, well, this will just be d sine theta all over r minus d cosine theta. All right, that was part A. Let us now solve part B, which, as a reminder, is to show that if d is less than r, then the trochoid does not have a vertical tangent. Here we need to be a bit careful about what we mean by a vertical tangent. I will make this clearer and more precise later on in the video, but for now, all we need to remember is that generally speaking, a vertical tangent is going to occur whenever the thing we're dividing by, wherever that's equal to 0. So it might be easier for us to, instead of asking what happens when d is less than r, maybe an easier question to answer is when does the trochoid have a vertical tangent? In other words, when I say when, for what values of D and R do we get a vertical tangent? Do we get a vertical tangent? Well, this might be a bit easier to answer now because, as I mentioned up here, this is going to occur when our denominator here is equal to 0. Recall that we just calculated this to be the slope. And when we divide by 0, we get plus or minus infinity, roughly speaking. So what we're going to do is set r minus d cosine theta equal to 0. And we're going to solve for, or figure out when this happens. So r minus d cosine theta is equal to 0. Well, if we solve for cosine here, what we're going to find is that cosine theta is going to be r over d. And, okay, we could solve for the angle theta if we wanted to, but it might actually be easier now to go back and now ask this question. So now we know when we have a vertical tangent, we just need our angle theta to be equal to, we need its cosine, sorry, to be equal to r over d. But if d is less than r, well, r over d is going to be bigger than 1. And this is a problem for this equation because you might remember from trigonometry that this side is always less than or equal to 1. So if we have that d is less than r, and therefore that r divided by t is bigger than 1, it's actually not possible for us to get this equality right here, because the left side is less than or equal to 1, but the right side is bigger than 1. So again, to emphasize, left side less than or equal to 1, but the right side is bigger than 1 if d is less than r. Therefore, for these values of d and r, when d is less than r, rather, it's not possible for us to get a vertical tangent anymore. And thus, we have answered part B. Show that if d is less than r, then the trochoid does not have a vertical tangent.